All right, so I'm using an old PowerPoint. A lot of this will be reviewed because, well, we've done this before. Ignore the chapter number because, well, we don't use a book. The unit we're really on would be 7. This would be our unit 7. Chemical reactions, but first we have to start with chemical equations. So first off, chemical equations. So first off, we're going to go with word equations. So equations, like to tell you what you're actually reacting, could be really long like this. Solid magnesium hydroxide reacts with aqueous lithium nitrate to produce solid magnesium nitrate and aqueous lithium hydroxide. And for crying out loud, that is really confusing to read. It's a lot of writing and reading. So how do we shorten it? The first step is we use symbols to replace words. So like plus sign is to, separate the chemicals. Arrow means produces or yield. Sometimes the yields word, you use S for solid things, L for liquid, G for gas, and then AQ, dissolved in water. So all those solutions that we played with at the beginning, like they're all aqueous. When you dissolve a chemical in water, it's aqueous. Solutions are all aqueous. So now to make our beginning thing even shorter with just symbols, we have this. It's words with symbols. So our magnesium hydroxide, you can see that, right? I shortened it with symbols and letters. And then, again, that's short, but we could also, those are called word equations. Like for crying out loud, we're not going to really do word equations, but that's what they're called. That's an improvement on the big, huge sentence, but it can be shorter. And how do we do that? By using symbols. Woohoo! And these are called skeleton equations. So there we go. There's magnesium hydroxide. Lithium nitrate produces magnesium nitrate and lithium hydroxide. That's it. So a skeleton equation just switches out the names with the formulas. Again, more stuff to know. All equations have 3 parts. Really, this should say review. All chemical reactions have the stuff you started with. It says before. This really should say starting chemicals. A beginning, change, and then an after. Like, okay, BCA, before, change, after. Like, that's what we called them this summer. We call them before, change, final, I think. Our starting chemicals are changing after. And fancy words for those, this again should be reviewed because we talked about this briefly. Reactants are your beginning chemicals. The arrow is what's happening, and then the products are the endings. Reactants and products. So we're going to shorten this. I do have the answer I'm going to click up, but if we were to do this in class, I would have you write them down. But let's just shorten this to symbols. So nitric acid, that's our chemical. So to shorten it, we would put AQ next to it. So aluminum, then you'd put an S. There's our next chemical. And then to produce, there's our arrow. Aluminum nitrate is our next chemical, and again aqueous, then it would have an AQ, and hydrogen gas. Okay, so I stuck this one first. Most people, when they first do this, would write H with a G. However, hydrogen has a 2 next to it, and why does it have a 2 next to it? Because it is a Hofbrinkel. We're back to these Hofbrinkels. Oh, there's the easy. Okay, so I used to use this before I'd even introduced Hofbrinkels, but since we've done Hofbrinkels already, so elemental things, anytime, pretty much all these Hofbrinkels, they're all gases. So if you see any of these as gas, you're gonna have to write a 2 next to them. But yeah, only when they're written alone. So when they're written or when they're gases. And we did this. So we did a experiment where, I reacted hydrogen gas and oxygen gas. Those would be H2 and O2. We're going to try this one. This is another practice. So again, shortening, here's our thing. So I'm just going to underline the chemicals. In liquid water, I guess I should name the words to produces. There's the arrow, sodium hydroxide, and hydrogen gas. So, okay, so now we have, and then, S, liquid water is the L, sodium hydroxide. It doesn't say. If it doesn't say and you don't really know, you don't have to write the symbols. Hydrogen gas is H2 with a G. So, there you go. If it helps to underline the words for crying out loud. I don't care. I just did it just to help. I got another practice, I think, and the only reason why I stuck this in here is because it's a reading thing. It says solid lead iodide and aqueous potassium nitrate are produced when aqueous lead to nitrate reacts with aqueous potassium iodide. So sometimes, but I'm not going to test over these that's a lie since we do multiple choice. I might have one multiple choice going from words to problems, but it's not the most important thing. But are produced means these two things, lead iodide and potassium nitrate, are our products. And lead nitrate and potassium iodide are our reactants. So that formula, and again, I hope I'm not going too fast, but we just finished the writing chemical equations unit. So the funny thing is you can't forget how to do that, because that's what the chemical reactions unit is. So that's what that would be. Just joking. I do have an example where you go from symbols to words, and it doesn't have to be long. And you could put, the symbols just tell you what it is. So you can say aqueous silver nitrate, or I don't have the answer to that one. So I'm going to write, so AQ, and you can just write silver nitrate, and AQ means solution. So heck, I'm going to write that. And sodium chloride, also AQ, also solution. React to produce. And then this one, I'm going to have solid silver chloride and sodium nitrate solution. Again, you could write, I'll write aqueous. AQUEOUS. That, again, in cursive. Aqueous sodium nitrate. That was a lot of writing. So for crying out loud, I'm definitely not going to make you do this. Pretty much all the homework is going to be which symbol means aqueous? You just write that. So it's going to be fast. Okay, and then just last, catalysts. So a catalyst is something you add to speed up a reaction. That's just what they do. But the key part about a catalyst is they do not take part in the reaction. So you don't put them on the reactant side, and you don't put them on the product side. Where's the only other place to put them? Oh, it's not used up. Really, I should say just not used at all. It's just, you just put it in, speeds it up. It's not used. So the place to put it is above the arrow in the reaction, because it's not a reactant and it's not a product. The only other place to do it is above the arrow. So anytime you see, this would say, in the written thing, it would see magnesium as a catalyst. A triangle is a shortcut for heat. So if it says, well, I don't know, hydrogen peroxide is heated to produce water and oxygen. Heated, you could write that, and for crying out loud, I would definitely not take off if you just wrote heat above the arrow. But if you see the word catalyst, it is not a reactant and it is not a product. It's written above the arrow. And again, hints to writing the equation, but I'm not going to make you do this. Just identify reactants and products, because they could be written backwards like that one. Write the formulas, and don't forget, these are all going to be ionic compounds, for crying out loud, except maybe carbon dioxide gas. There's your that's pretty much the only molecular compound we're going to deal with, carbon dioxide. So pretty much every time you have to pay attention to charges, use your periodic table. Check for Hofbrinkel's, any of these, hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, chlorine, gas. Anytime you see the word gas next to any of those. There's Bruce, the guinea pig. Those get 2s. H2, etc. Right catalyst above the arrow, and again, all elements on the reactant side must be on the product side. So you're not going to write sodium hydroxide on one side and then have sodium and oxygen without no hydrogen. Like, that's what that means. Oh, we're not going to do writing equations worksheet, so I'll put up, a couple problems. Actually, we will be doing writing equations worksheet. It's just not going to look like a worksheet. So there you go. Hopefully that's not too long and confusing. I really wish I could see your guys' faces, but you'll see me tomorrow.